Magnetic flux is the last heavy mathematics thing to learn in this unit. The magnetic flux symbol is the Greek letter iota with a subscript b to indicate it's magnetic, and equals BA cosine theta. So again, cosine theta, just like sine theta, is a number between 0 and 1. In this particular image here, you see that the cosine of theta would be maximized because the magnetic field lines are able to pass right through this rectangular loop of wire. If I took this rectangular loop of wire and I rotated it 90 degrees, not 90 degrees this way, not like this, but instead, so that way the left end of the wire here comes out of the screen towards your face, and the right end goes into the screen behind the computer screen. So effectively, on your point of view, you would virtually just see a line like so. That would give us a cosine theta equals 0, and no flux would be passing through the loop of wire. If I continue to rotate it another 90 degrees, we would be back in this position. So for the most part, again, we're going to just call this cosine theta equal to 1 because we're looking to maximize things. Once again, to identify our variables, the iota with the subscript b is magnetic flux. There is electric flux as well, which we do not get into. Magnetic flux is measured in a unit called Webers, WB, Webers. And B is your magnetic field. The magnetic field, again, Teslas. And A is the area. And that area A is in square meters. So if I want to figure out what is the magnetic flux through this loop of wire, I'm going to need to convert the length and width of that rectangle into meters. So 0.05 meters and 0.02 meters. I can now figure out the area. Area is length times width. We should know that by now. 0.05 by 0.02. So 0.05 times 0.02 is 0.001 square meters. Let's move this down to give myself some more room. Cool. So the magnetic flux passing through this loop at its maximum position is going to be BA cosine theta. Cosine theta is a 1. The magnetic field strength is 30 microteslas, so 30 e negative 6 times 0.001, and punch that into a calculator, we get 3 times 10 to the negative 8th Webers. Let's move on to the second one. What is the maximum? Again, here we go, maximum. So we're going to set cosine theta equal to 1. The maximal magnetic flux that can pass through a circular loop of wire with a radius of 4 centimeters. So the area of a circle is pi r squared. So this would be pi times, we have to convert the centimeters to meters, so 0.04. Don't forget to square it. Pi times 0.04 squared is 0.00503 meters squared. Now we can use our new flux equation, BA cosine theta, which we already said cosine theta is going to 1. B is 5 milliteslas, so that's e negative 3. The area is 00503, or 5.03 millimeters squared. And our final step, 5 e negative 3 times the area, and I got 2.51 e negative 5 Webers. The wonderful thing about flux, you don't have to worry about direction. So Yep, that's a wrap.